Hello, it's Dumplet here. Here's an item on algebra. Let a, b, c, and d be real numbers such that a squared plus b squared plus c squared plus d squared equals ab plus ac plus ad. Find all possible ordered four tuples a, b, c, d. As usual, pause this video if you'd like to give this item a try. But if you're done, let us dive into the solution. Now, the first step is very obvious. It's very obvious that this part is factorable, and we can try to see cases here because, so for our case 1, we want to see that, okay, we can factor out a, so it's going to be a times b plus c plus d. Now what's nice about this is that we know this, it's greater than or equal to 0 since it's just a squared plus b squared plus c squared plus d squared, so these are all squares. So I guess it will be logical for us to say that, okay, case 1, let's consider a equals 0 or b plus c plus d equals 0. Because, why not? Because that's the minimum bound, or sorry, the minimum value of the left side. So if a equals 0 or b plus c plus d equals 0, then it would be obvious enough that we would have a squared plus b squared plus c squared plus d squared. That's going to equal the right side, which is going to be 0 anyway. So since we know that this part is greater than or equal to 0, so we know that each of these, a, b, c, and d, must be 0. So we have the solution already, a, b, c, d. That's going to be 0, 0, 0, 0. And this is the obvious solution to this item. So that's for case 1. Now case 2, well, we should consider the other cases. So for case 2, we're going to say that a is not equal to 0 and b plus c plus d is also not equal to 0. So the other case. Now, if it's not equal to 0, then we can do the following. Now, since we have a homogeneous equation, homogeneous meaning, look at the terms, we all have degree 2 here on the left side of the equation, and we have degree 2 in the right side of the equation as well. So degree 2, degree 2, degree 2. So we have a homogeneous equation. So all the terms are of degree 2. Now, if we have a homogeneous equation, we can do the following. We can let b plus c plus d equal to a certain value. Now, this is valid in homogeneous equations, so do remember this trick. So I can literally make b plus c plus d anything I want. But to make it simple, let's make it equal to 1. Now, if I make it equal to 1, the equation will simplify as follows. So a squared plus b squared plus c squared plus d squared, plus d squared, that's going to equal simply a times 1. So b plus c plus d becomes 1. So it's going to become this. Now, we can do a little bit more since we have b squared plus c squared plus d squared, and we can use the well-known identity of the Cauchy-Schwarz inequality again. Now, by the Cauchy-Schwarz inequality, sum of squares, so b squared plus c squared plus d squared times, well, 1 squared plus 1 squared plus 1 squared, which is equal to 3. And we know that this will be greater than or equal to b plus c plus d squared, as per CSI, or the Cauchy-Schwarz inequality. Now, since b plus c plus d, we let it to be 1, we know that this one, b squared plus c squared plus d squared, this is going to be greater than or equal to, this part is 1, so 1/3. Now, we can substitute it into this equation, or we can just simply use the fact that, okay, I can add a squared on both sides. So, and this part, it should be equal to a. So I'll have a would be greater than or equal to 1/3 plus a squared. So we have a quadratic inequality in terms of a. Now, we can try to solve this inequality. So, well, this part is a. So a would be greater than or equal to 1/3 plus a squared, and then multiply both sides by 3. So 3a will be greater than or equal to 1 plus 3a squared, and a little bit of spoiler, but it's going to equal this. So all we have to do is solve for a in this equation, but we can factor it as follows. So I can transform this equation to, I can factor the 3 out, and I can make it a squared minus a plus 1/4, since this will be a perfect square. Come back to this in a second, and then plus, I'll add 1/4 and less than or equal to 0. So these two are the same. Now the inside here is going to be equal to a minus 1/2 quantity squared plus 1/4 is less than or equal to 0. Now take a look at this. This part is greater than or equal to 0. This part is greater than or equal to, well, this is 1/4 already. So left-hand side, so LHS left-hand side is greater than or equal to 1/4 technically. So 0 plus 1/4. Therefore, case 2, no solution because there are no real values of A. So from case 1, A equals B equals C equals D equals 0. And from case 2, we have no solution. So we've covered all possible cases. Therefore, the only possible solution for A, B, C, D is the solution, is the 4 tuple 0, 0, 0, 0. And this will be our final answer. Hopefully you guys learned something new from this video, and I'll see you in the next one. Bye bye!